Let's solve the following physics problem. So state the principle of conservation of linear momentum. State the principle of conservation of linear momentum. So in a closed system, the in a closed system with no external force, the momentum before collision is equals to the momentum after collision. That's the principle of conservation of momentum. So remember, you have to state that in a closed system, the momentum before collision, mv, is equals to the momentum after collision. So fig 4.1 shows a form of a shotgun approaching a suspended piece of cork. The pallet has a constant velocity of 2.1 meters per second. The pallet strikes the cork and gets embedded. The system swings about the fixed point until the string is horizontal and falls back. The mass of the pallet is to 9.2 grams and that of the cork is 5.6 grams. Right, let's go to the questions. Calculate the kinetic energy of the pallet. So let's calculate the kinetic energy of the pallet. Calculate the kinetic energy. So EK is equals to half mv squared. That's going to be half mass of the pallet, 0.0092, multiplied by velocity of the pallet squared, which is going to be equal to 2.03 joules. So this is the kinetic energy of the pallet. The velocity of the cork in the pallet just after impact. So the velocity just after impact. So we are going to say that the mass of the pallet, momentum, we're going to use the principle of conservation of momentum, is equals to mp plus mcv. So this is the momentum of the pallet and the velocity of the pallet, and this is the momentum of the bulb, the cork here, and the velocity, the initial velocity of the cork. This is going to be equal to the combined momentum of the system after the pallet has hit the cork. So subject of the formula, our V is going to be equal to mp vp plus mcu over mp plus mc. We substitute into the formula. That's going to be 0.00292 multiplied by 21.0 plus. So this system, this cork was initially at rest, so our u is 0. This one is 0. It didn't have momentum before it was hit by the pallet, over 0.092 plus 0.0556. So our velocity of the system after impact is 98 meters per second squared. Per second. Let's move on. The length of the string used. So the length of the string used, we want to see the length of the string that we used. So here we are going to assume that EK is equals to EP. So EK is equals to EP. So EK is half MP plus MC. V squared is equals to mgh, which is combined mass, plus MC G height. So these ones they cancel out, and we have L is equals to V squared over G, 2G. So we substitute into this 2.98 squared all over 2, 9.8. That's the acceleration due to gravity. So our L is going to be equal to 0.453 meters. So now let's do the last part. State two assumptions made in this calculation. State two assumptions made in this calculation above. So let's talk about the first assumption that we made in this calculation. So we assume that there is no external force. So we assume that this is a closed system. So second, we assume that the collision is inelastic. So those are the two main assumptions that we made.